Welcome back for another podcast on integration by parts. For this problem, we're going to look at the integral e to the negative x cosine of x. Now, the key to learning about integration by parts is to do plenty of different types of problems. Doing the same problem with small differences is not really going to help you understand the process. But looking at problems that differ in ways that require you to think about the problem with a slightly different pattern is what I'm trying to focus on. So in this problem, we have an exponential function and a trigonometric function. Well, those actually allow you to choose your dv and your u without worrying about making a mistake. In other words, you could probably do this problem by making dv cosine of x dx or making dv e to the negative x dx. Some other problems that's not true. I'm going to make dv equal to cosine of x dx. And if you remember your differentiation formulas, you can probably understand why I'm choosing that. So that's going to make u equal to e to the negative x, making du e to the negative x dx. And v is simply sine x. So now, using our formula for integration by parts, I have that the integral is equal to my u times v, which is e to the negative x sine of x, minus the integral of negative e to the negative x sine of x dx. As you can see, we have a negative situation. So I'm going to fix that very quickly by just erasing. Oops, got a little bit of the E there also. I didn't mean to do that. It's the beauty of Smartboards though, right? I can clean this up a little bit. And I'm going to make this back into a plus. And so now I'm looking at this integral right here. And of course, it looks like I need integration by parts again. I have my u and my dv, and I'm going to make my dv sine of x dx, and making my v negative cosine x. That makes my u e to the negative x, and it makes my du negative e to the negative x. So using that information, I can now work out our final product. So we have that e to the negative x cosine of x dx is equal to e to the negative x sine x plus, and this is when I'm going to use my integration by parts a second time. This will be negative e to the negative x cosine of x minus the integral. Now notice the signs. Look at the signs of v and du. Of course, I left something off here. Left off my dx, so we'll put that in. The negative cosine x and the negative e to the negative x give me simply a positive e to the negative x cosine of x dx. So I'm in luck now, because as you can see, this is exactly the same integral as that, which I can then add over here, giving me 2 of those And so, if I divide both sides by 2, reduce out the 2 over 2, my final answer is that.